Welcome to the lecture of disaster management. So here we'll be talking about landslide hazard zonation. So here you can see a map which basically shows various degrees of landslide zones: very high hazard, moderate, moderately high hazard, low hazard, and very low hazard. So you can see the different shades that have been provided. So in India, if you see, the landslide prone areas are mostly there in the northeast, and then towards the west coast, right? So this is basically a map which shows the various regions where landslide hazard ranking has been given, whether it's high or low. So this is what is landslide hazard zonation. So talk about the definition. Landslide hazard is basically shown on maps which display the spatial distribution of hazard classes. Or landslide hazard zonation refers to the division of the land in homogeneous areas or domains and their ranking according to the degrees of actual or potential hazard caused by mass movement. Right? So it's basically a map which shows the different classes of landslide hazard that is possible. Here you can see on the right picture of landslide that has occurred in India. So you can see that it's a very significant disaster which has to be taken care of, and it affects India every year, especially during the rainy season. Because of the rainy season, the soil loses its integrity and then the land slides off. So it's mainly observed in Himalaya areas, northeast India, Nilgiris, western Ghats, and eastern Ghats. So every year there's loss of life, infrastructure, and property. So in India, if you talk about the landslide effect, around 15% of the land area has been affected by landslide, and it is also increasing nowadays because of growing population, unplanned urbanization, industrialization, and there's rapid development in high risk areas, environmental degradation, and climate change. So the impact of this is more severely felt by the socio-economically weak people because they are habituated to living in hills, and these areas are vulnerable. So next, one of the important things when landslide hazard zonation map is made is slope stability analysis using GIS. GIS stands for Geographical Information System. So what they try to do is they try to analyze how stable is the slope of a land in a particular area using geographical information system. So recognition of site and choice of mechanical characteristics of soil, stability calculation to determine what will be the failure curve along which the slip risk is highest, right? So and then they find the safety factor. So slope stability analysis can be made for 2D and 3D analysis. So in case of 3D, it's very important that we need to understand the area, how the geometry is present, and how is the surface, in which direction, what are the material properties of soil. So all this is important. So GA is a new software tool that is used for landslide susceptibility mapping, and then it also provides various functions of capturing, manipulating, visualizing, modeling all the geospatial data. So if you have a particular hill or any particular area which you're considering, that can be geographically mapped using the software tool. So it can also be used for slope stability analysis. So GIS is a framework that provides ability to capture and analyze spatial and geographical data. So applications are basically computer based. So there is user interactive queries that can be put, and then you can vary the different coordinates, different slopes, etc. And then finally you can find the stability of a particular slope. So on the right you can see an example. So suppose that is a studied site. So you take the coordinates, you find the digital terrain models. So DTM is nothing but whatever be the studied site. So for that you make a topographical survey, and then slope and aspect have been determined for each pixel of the studied site. So in your studied area, you determine the slope of all the different points. And GIS is mainly used for slope stability analysis in both 2D and 3D. There's a formula which is called Hovland formula, which is nothing but the ratio of total available resistance along the failure surface over the total mobilized stress over it. So what Hovland formula tells us is finally we determine what is called the safety factor. So using this safety factor, we can get to know whether the slope is stable or it is not stable. So if you see amongst 2D and 3D, the safety factors in 3D are always higher when compared to that of 2D. So GIS can be used effectively for 3D and 2D slope stability analysis. Using the slope stability value, we'll get to know which part of this site is more prone to landslide. So we'll do a case study with Panchgani, Maharashtra. So that is the hilly areas which are affected because of the rainy season. So using this landslide hazard zonation, we'll get to know what are the various points where the landslide hazard formation is very high, and then accordingly this method is being used. What we try to use is remote sensing and the tools of GIS like ILWIS software. So it's basically a software which is a part of the GIS. So the data which is basically collected from Survey of India and Geological Survey of India and satellite images, using all that the measurements of the whole area is being captured, and also the various values of slope, drainage, how's the flow accumulation, everything is being generated using this GIS software which is ILWIS. So using this software, we kind of make a model of the whole area. So that is the data. And next we give input parameters of slope, drainage, lithology, land use, slope aspect, roads, pre-occurred landslide settlement. So all the previous data is also being input parameter, and then the outcome of image processing is basically a set of thematic maps that are utilized as data inputs in different layers. The data is integrated using GIS technique to analyze the layers, right? So you have the model of the whole land, and then you give all these parameters, like you give slope values, you give which part of the land is being used, and what is the angle, where are the roads. So everything is being provided, and then the outcome will be a map. So the slope map in degree is a very important layer in landslide hazard zonation, because slope is the main reason for landslide, right? So there are different colors. Blue color basically for slope from 0 to 13 degrees, yellow for 13 to 50, which is slight prone, and then 50 to 90 is definitely steep stable slopes. So these are mentioned in the software, and then it's also calculated the landslide hazard zones in different ranks: very low, low, moderate, high, and very high. How much area of total area, the percentage belong to these different zones. On the right you can see the image of landslide hazard zonation, right? So where the dark red is very high and light blue is very low. So if you have a hilly area as such, you'll get to know which are the regions where landslide occurrence is more prone. And if you talk about the results, this case study has been done in Maharashtra using GIS for the very first time, and it has very clearly defined all the 5 risk zones. And in this research also the susceptibility map has been provided, which says that there is a possibility of which zone is more susceptible to landslide and which is safe zone, right? So that can be seen in the image. So here you can see of the total percentage of total area, which is 100, out of which there is around 90.82% where there is no infrastructure, and then you have around 3.4% safe roads, and vulnerable roads are around 0.63%. So these roads are vulnerable to landslide, so they can close it during the rainy season. So that is the effect of, that is the overall result of this case study. And you also have vulnerable places as 1.4, and you also have these non-vulnerable settlement as 3.74%. So you get to know which all roads have to be closed and where there is more possibility of landslide occurrence. Thank you.